Well, hi, and welcome to my shop. That radio has a tail. Can you see the tail on that radio? So, Shadow and I are going to be in here starting today. She abandoned me yesterday after a few minutes, but maybe today she'll stick with me. And what I'm focused on is the field coil replacement resistor, which I removed yesterday. This is what I took out of the radio, which is connected down here. And I'm thinking about replacing this because this particular combination of resistors is not terribly effective. That's a 500 and a 125. So the 500 is doing all the dissipating all the heat, and this guy's getting a little too warm. So I want to replace it, but of course, I don't have a big stock of high wattage resistors of all kinds of values. So this is not the easiest thing. I stock 5-watt resistors. A couple of those in series would do the trick, but I actually don't have the appropriate sizes. I don't have two 400s to put in series. I'm aiming for 800. What I do have is I have this resistor, which isn't damaged or anything. There's nothing wrong with it. That came out of the set. That's a 500 ohm one. And I have this one that I pulled out of my junk box. This guy, also in great shape. He's also 500 ohms. I just clip off this one here. So I can do this. I can take two 500 ohm high wattage resistors, put them in series, get 1,000 watts. 1,000 ohms rather. Yeah, not 1,000 watts. 1,000 ohms. Replace the existing combination, here it is here, which is 630. And push it up to 1,000. So I'm almost doubling this. Now the resistance of the field coil, according to the schematic, is 800 ohms. That's a pretty round number, 800, so I'm guessing it's 750 to 850. So what if I push it up in resistance? Or let it go down and just put a 500 in? Well, if I put a 500 in, this one would be better than this one. This one would stay cooler because it's so much bigger. But it'd still be getting pretty warm in there. So I'd rather not rely on one 500. That would reduce the voltage drop. It would increase the output of the power supply that we're considering putting this in. That would raise the B plus and cause all the currents, all the tubes to work a little harder. And I'm pretty sure the B plus developed here is feeding the 245s, and we really don't want to raise that too much. I already measured it high with the 45s out of the circuit. I measured it high with this in place. Increase this resistance a bit. I'm going to drop the B plus a little bit. I think the 1,000 ohms is a good thing to try. I'll put these two half kilo ohm resistors in series. Stick them in here. If there was some way I could clamp them in there, or because see, these have a fair bit of mass to them. So conceivably, if the radio is in the back of a truck bouncing down an old country road, this part would be flexing up and down relative to the chassis. It's going to flex its connections. In fact, look at the connections on this. These are great big tabs here. My cat has continued to hide behind the radio. What exactly is she doing? There's the cat. Poor cat can't go outside. Weather's not good enough. She's a little beside herself. Okay, well, I don't think any better ideas are going to come. I don't have many options with resistors anyway, so I'm going to work away at putting these two big 500 ohm high wattage. This has to be at least 5 watts. This looks like a 10 watter anyway. This should work out. In the worst case, we're dropping the B plus down. That only protects the radio. We're increasing the thermal dissipation off these resistors. We'll find out what the result is ourselves through measurement and observation. Yeah, I think it's a good idea. Okay. Shadow, you just going to stay back there the whole day? Is this your plan? What is your plan? Shadow. Good cat. Okay, so I'm going to be kind of cleaning up and fixing up the combination of resistors here. I'm going to leave that wire on there. No. Don't play with my soldering. No. Is that why you're in here, looking for things to play with? Get this fused up pretty good, but I have to make it fit in the radio too. Can't ignore that fact. How do I want this? Sitting back there like that would be nice. Let me bring this one kind of forward this way. If I make one connection with a piece of wire, then that's the flex connection. I can accommodate wherever the more rigid connections go. So I could do this like this, just like this, that up there, this up there. Something like that would work. I think something like that would work. To put a wire off of here, perhaps. If I put a wire off of it, then I can make this come out like this, just really long. Any way I like. I could even do it like this. Any which way, as long as it fits in there, if I use a wire. So these terminals will get hot. The heat's gonna, and they're intended to, whoop, over here. So these terminals will get hot from the heater, from the heat in the resistor, and they're intended to get hot. It's part of the cooling system. Maybe intentionally, maybe unintentionally. What you hook these to is going to draw some of the heat out. So solder that solidly into the base of a tube. Maybe that's not the best thing, because the tube is trying to cool off, and you're not helping by pumping heat from one of these. But if you have a wire extending it like this, well, the heat will have a much harder time traveling down this wire. In fact, it really won't. This really won't travel down here. So that will drive the temperature of the resistor up higher because it doesn't have the cooling effect out there. And laying it up, these are hollow, right? Laying this up in the radio against the chassis somehow, so it's in contact or extremely close to the chassis, probably help dissipate the heat. Having it out in the open here, not so much. There's no real airflow under here. This is all stagnant air. No, there'd be some airflow because of the heating from this, but I think we're better off like this, if I can do it. And then that would leave this one kind of airborne. This is all fiddly small stuff here. This is not a serious, space shuttle issue here by any means, but might as well try to figure out the best way to do it. So I think that's the way. Maybe I'll. I could do it like this. I could do it like this, and then extend a wire up from here up to the. You know what? I think that's the best way to do it. I think I'm going to get the best result. I would leave them both laying flat. Of course. Now they're here because of just a flexible wire. So these two connected together is going to be a fair bit of weight there. So see, normally these would be soldered right onto the posts of a terminal strip. What if I do that? I got a perfect screw right here. It's good space in here too. If these were sitting on a terminal strip up in here. I like that idea. Thank you. I'm going to work on that. Okay, so I've got a terminal strip at the ready there. what we'll do is we'll try to connect this in the best way possible. So I was able to actually thread this through the hole over here. I'm trying to do the same on this side. Okay, I should be able to solder this back quite nicely with this. Solder that in, that's pretty good. Now the other one would then want to go, ooh, careful now. This way. I want to stay away from this particular terminal because it's grounded to the chassis. Oh, wait a minute. Is this no, this resistor is not grounded in any way. So we come back from here to this one. So we bend this tab forward and plant this like this. I need a little wire to wrap around these guys here. A little big piece of junk wire. Surely to goodness I have some junk wire laying around just to grab. No, I do not. Yeah, that's the one thing in my shop that's hardest to find. That's wire. Okay. Ready? Okay, that's the two of them bound onto these terminals. Now I really want to come back this way. Stiff terminals, so I don't want to strain the little rivet area there. Wow, I don't know if I can get it this way. inside, but I don't think that's really a problem. Clamp this too tight, you know, it's porcelain, right? Too tight, it's going to crack. It's just tacked on there. A little bit. Yeah, it's not hot. This is intended to draw heat quickly through itself, right? So if you apply heat here, it's going to zoom up inside. Okay, then we get it where we want to get to here. I think it's this connection that's going to be tricky. This one over here won't be too tricky. I have to bring the lead wires into the picture too. Should make the lead wire connection at the same time and make the final solders here, because if I do it any other way, I think I'll be caught unsoldering what I've soldered up. So I need some lead wires now coming out of there, Need lead wires, but more wire needed. Okay, so I picked some fairly heavy duty stranded wire here. It's a nice yellow color. I need a fair bit of bared off copper to kind of come and wrap. Cut this back a fair bit. Come up through the hole. This is the terminal that's going to receive, no, this is the one that's going to receive the other resistor, right? So this is it for this terminal. Just bring this up and around. Okay, so that's going to solder up really nice. This huge wire on it. Half of it. Is that really so? Better just take a quick look here. Make sure. So this is going to be. 1 second. Okay. So this is going to be under this screw here. And the wire has to make it down to here. And over to there. Yeah, you know what, I can just cut this right in half. I am notorious for cutting wires too short. My plan is always to cut them longer if needed after I've cut them short. So this guy's going to go up, he's going to do double duty. See, I've cut this too short, I bet. No, should be okay. No. Lots of wire now. And the other end, not so much wire. Okay, now we got to do the double. Gotta get all this twisted around. Oh, was I doing this? I hope I wasn't doing that. Well, I don't know how I got it all twisted around, but in fact it's in better position now to connect it. It's actually better this way. Oh, okay. That's great. Put that there. Now, it's a bit of a challenge here. I'm going to twist this around and lock in the other resistor. Lock being a strong word. Oops. And then this guy is supposed to join in here. Back off a little bit of that wire. Get under there. Come on, you can do it. You wouldn't want to work these terminals too much on the ceramic resistor because it might crack. Well, looks like a job for a lot of solder. Okay, there we are. Two resistors in series, tucked up pretty close to each other, and two leads coming out. Okie dokie. Let's solder this guy up. Soldering iron is running at 310 degrees C now. There's going to be a lot. So these resistors are extremely rugged for heat, so I really haven't got too much to worry about here in terms of heating up the soldering iron, or heating up the resistors rather. Nice big solder blob here. It stayed hot that long. I think I generated a cold joint there. So we'll heat her back up. I figure a short burst of breath blows off a lot of high heat quickly. So a little puff can do it. Well, drive off the highest temperatures quickly. Good. Like that. Now, this last one. cool. It's cool to touch. Looks good. Looks very, very good. That didn't quite feel right. Poorly soldered here. I didn't get it on the back. There we go. Good. She's as solid as can be. Excellent. Now we're going to stick this in the radio. These wires coming up like this. And you stick it right under there. So we got this wire here. Move up this way. And we got this wire here. We're just going to move it off to the side a little bit. Try and get that in there. Fit on the screw, please. Okay, the hole's not big enough for that screw. It's not one thing, it's something else, isn't it? So do you make the hole bigger or get a smaller screw? Making the hole bigger is actually a tricky business. You start trying to drill into there with anything, it'll bite the metal and then twist this right off, and then your wonderful solder job will just be wasted. So I'm not going to do that. I'm going to look for a smaller nut and bolt. Okay, and we'll get that bolted in there. My cat is losing patience and wants to go outside very badly. Another interesting question comes, why put this plate back on? I'm going to have a couple hot resistors right below where this plate is installed, and the plate is covering. Look at that. That didn't quite work right. Thought it was the right size. So I could leave this plate off, and underneath there are two nice holes there for venting. I'll ponder that for a little bit. Is that a smart move? I don't think so. I don't think we're looking for venting here. Get my new screw out. Nut and screw. It's not the longest screw in the world. Okay, leave the locking washer on it up above. And here's my resistor guy here. Maybe a little better off looking at it this way. Well, I'm guessing that's original to look like that. Original cover plate. Makes sense. Maybe not. just my kind of guess on things here. How did this come out so easy? And we just have to chop a few wires on the way in. Get my hand screw left? Oh yeah, lots of screw. So we're gonna try to sneak it by here. Very short wire goes straight into this, right through the zone of interest. Oh my gosh. It's gonna do it. That'll do it. Gotta get this to start. Can't really see it, but my other hand, yeah, you can see it. My other hand's around the back of the. I got it. Let's try. I think this yellow one. I should have sized this up. Okay, finger back on it. There we go. Okay, now, final position of the resistors. Well, that's pretty good, just like that. These yellow wires are a little bit of a problem here. Let me tuck them under that. There we go. Freeze that guy right in there like that. Okay, anything going wrong here before I really put the power to it? The wire's long enough to get to where they need to go. Must be. Okay. Okay, we're gonna go the goods here. There we go. There they are. Now I just have to remember what terminals they were hooked up to. I've kind of lost complete track of that. Like a dummy. Should have made a very careful note of that. But you know, you're doing something and you think it's only going to be a minute before you do the next thing, and then it ends up being 6 hours later. You do the next thing. At least that's what happens here in my shop. So one wire is going to go somewhere here, and the other one's going to go somewhere there. I think I know where they're supposed to go. But I need to find out for sure. Okay. Good to hear. Okay, so my older cat has come down here now to see what the problem is. Why can't we go outside? And the main reason is because I'm just here. That's the main reason. Okay, get my soldering iron going here. So you can see the two yellow wires are now on the connections where they need to be. Just had to look back on an earlier video to see that for sure. Okay, I'm ready here. Okay, so I'm operating my mouse with the left hand. That's why nothing's happening. Here. My older sister was left-handed, and they tried to beat it out of her in school because that was the standard practice back then. Save left-handed people from themselves. And she ended up ambidextrous. She ended up able to write well with either hand. It's kind of interesting. I think the last thing you want to communicate to a young child is that there's something wrong with them. Parents certainly like that standard parental phrase from back then. What's wrong with you? I must have heard that. I must have heard that a million times from them. eating the solder here. It's going somewhere. I don't know where it's all going. That's got to be soldered up. Now, this one here. Yes, what's wrong with you? I ought to give you a swift kick. That was another one I heard a lot. Parents of the 50s. Well, actually 60s. But I'll tell you something they taught me, and they didn't do it on purpose. I just got it somewhere. Maybe not even from them. The golden rule. The golden rule. My God, there should be a law in countries saying the governments must follow the golden rule. Now, you know what? The golden rule and a couple others are all you need to sort out right from wrong in life. And it seems like the golden rule has been thrown on the trash heap completely. Because you can't have a me society that follows the golden rule. Those two things are polar opposites. And right now we got a me society going. Me first. Okay, enough of that. Enough of that. Enough of that. Get off that topic, Jim. So she's in. So I think that's just the way this is built here, making that. Now what I'm looking for are loose connections. Okay, I think we're good. I think we're quite good. I think we're good enough for a test. What do you think? Let's give it a test. So to test this properly now, I guess we got to listen to it to listen for a hum. I know, so I can get that metal plate on there perfectly straight, but that's okay. You know, maybe I can move it. Nope, can't move it. Not a problem. We can fire this guy up as long as we're listening to listen. Okay, I've got to set up some equipment again so we can listen to it. Okay, so somehow I've convinced my cats that I'm just non-responsive, and they've just given up and gone off somewhere else in the house to probably goof around with each other. Now, so what we're going to do here is we're going to turn this guy on. We're going to immediately wonder, did I mess this thing right up? So the immediate that I mess this thing right up is those lights. If those lights come on super bright, disaster is afoot. Of course, I can interrupt disaster at that point. So if the lights come on and do the normal thing, the next question is, so how hot is this thing getting? And how high is the B+? Those are the next two questions. I want to answer them as quickly as possible. So I have a meter hooked up here to read B+. Pretty sure I've got it on the right. Well, I got it on one of the capacitor terminals in the filter, so we're going to get some notion of what the B+ is. And closer to the transformer, a little higher. A little closer to the radio circuits, a little lower in terms of there being a couple of choke coils and capacitors and whatnot. So don't know exactly where I hooked it, but somewhere in there anyway. Expecting around 300 to come up here. And then to do the temperature thing, I'm going to grab my temperature meter here. Let's get it going. Get it set up. So look, I must default to 35 at the red and 10 at the blue. So I'm going to adjust the top one and expect these to get up to 50 maybe. So what we'll do is we'll set this up so red starts just below 50 on the screen here. And we can change the bottom one too, because it's pretty low. 10? No, that's... Oop, what did I just do? So I changed the emissivity. So one of the things I don't talk about when I whip this out is emissivity. Emissivity is the ability of a material or a body or a surface to radiate heat at a certain temperature. And different materials radiate different amounts of infrared radiation for the same temperature. This guy's too stupid to know that on his own. He doesn't know what you're looking at. So the worst case is shiny metal. Trying to read the temperature of this shiny metal. That would probably be way off on this kind of thing, any kind of infrared instrument. So to compensate for that, in case you want to read the actual temperature of some shiny metal or some material that has an emissivity issue about it, there's an emissivity adjustment here. Now it's set to 0.95, which is pretty darn close to 1. 1, I don't know, that's the emissivity of some standard thing, I don't know what it is. Most things are 1 or a little bit below. So having it set to 95 or 90 is fine for pretty much everything, as long as you keep in the back of your mind, if you look at shiny metal or some other particular surfaces, this thing is not accurate. It's way off, in fact. But for our normal use, it'll be fine. Okay. This one, by the way, came from Banggood. If you're interested, but there's others available, but this one's fairly inexpensive. And the temperature, yeah, the temperature is going up and down. So are the prices of these things. So if you want to get one, keep your eyes peeled. Okay. Now I gotta kind of come off the speech there and get my head back in the game. Here, is there anything else to be concerned about? So the sound again is going to come out on this cable. I've hooked it up to the volume control. The volume control will affect the output coming into this cable, which is on its way to the audio system that you are listening to until I put these headphones on. Once I get these headphones on, I am listening. I am listening too. I don't hear much. You know how tricky it is to hear your own voice. Okay, I think we're all set. So let's go over here. I'm going to get a chance to watch the first test, dim bulbs. And the volume turned down on this, right to nothing. B plus, you can see it. Because I'm fooling right in the power supply here, I'm just a little cautious about this. I don't want to make mistakes in this particular arena does not tolerate errors very well. And just in case a big pile of smoke comes pouring out of there, I better get it on camera. And now my own position is a problem here. I'm going to move this up. Good. Still see the meter. Still see the smoke. Still see the switch. I flip the switch downwards. The lights are engaged. Upwards, the lights are not. Okay, that arms my system. Flip this down, and we start seeing stuff. But first, probably a lot of you who have watched a lot of my videos must wonder if I do this on purpose. And I forget to plug the thing in. No, I don't do it on purpose. I forget to plug it in. Okay, there we go. Special safety feature, and it worked. This time it's going to go. Watch those lights. Okay, they're perfect. They just came up slowly. They didn't get very bright at all. And they're kind of pulsing up and down a little bit as tubes draw current and things like that are happening. Voltage 400 volts coming down, coming down. Now remember, I don't have these two power sucking tubes plugged in. These are 245s, so this is liable to be high. But there's a lesson in itself. For all these radios, even the little tiny 5-tube guys, when you first turn them on, there's a voltage shot that goes through for a while. So although ultimately maybe it's going to run at 340, which seems a little high to me. Is it really? Let's just double check here. I think it's 275 on 45. That's what I remember. So 275 is the maximum plate operating voltage shown here for a 45 tube. And minus 56 on the... So here's the thing. I give this guy full power. What's he got right now? He's got 100 volts. If I give him 122 volts, This is going to go up to, what do you think? Hey, wow, how's that thing getting? I haven't even checked. 0 heat. Oh, that's not a good sign. 0? This is bad. This is bad. Oh, okay. Well, is it really 0? Stick your finger in there. I don't think there's any heat in there. I've done something wrong. Something has gone wrong. Well, okay, well, do we really know something's gone wrong? Let's try listening to it. So I'm going to turn the volume up a touch on the radio, and now on my control system over here. Here we go. I booped it up. I have booped it up, I think. Let's turn the volume up higher. Oh, I don't have an antenna. Okay, so you can hear the effect of the volume anyway a little bit. Okay, antenna. I have the antenna at the ready. I didn't mention that part. It's surprising how quiet these radios can be when they have no antenna. I've got to move the camera here out of my way. Okay, too many things going on at once. Let's bring this around. Make sure the volume's down. Watch out, don't hold two things at once. Here we are. Antenna connected. Actually, it's just more wire. Volume up.
Release codes, all the fish are released where they're caught, and for me the better thing is, especially in walleye and muskie events, you don't have to worry about slot limits anymore. If you don't have to worry about one
Fishing
walleye over 18 inches, you can now weigh in, if you will, your 5 biggest walleyes because you're just photographing and let them go.
And the best part to me, no culling. I hate
No culling.
that whole process.
And if you talk to the guys who doubled at Major League Fishing in the U.S. right now, it has gone to that format. And it is now being on the 3 national television. It's now becoming mainstream on the big television, live. And all of the guys, the tournament anglers, Aaron Martins, Kevin Van Dam, all the guys, Octaful, they're all saying, this is the best thing we've ever fished, and every fish counts. We don't have to worry about it. Never turn on the live well.
I think that's the future, man. I do.
62
It's going to be great. Gordy, thank you very much, buddy. An extended version of Gordy. It's a pleasure, my friend.
It's always fun, Ange.
Gord Pizer, the Doc. We'll talk to you next week, my friend. That is it for us. We are out of here, Steve. On behalf of the entire Outdoor Journal team, Stephen Lavity, John Winters, Derek Rendale, Jessica Ellis, I'm Angelo Viola. Have a great weekend, folks. We'll talk to you next Saturday.
Okay, next Saturday. So what I'm going to do now is I am going to raise the power input to 120 volts. So it's just like it's plugged right into the outlet. It's no longer going through my little dim bulbs. And we're going to find out what happens to the temperatures, the voltage over here, and everything. That'll be the last step for today. It's just the tiniest amount of heat in here. Well, what is the actual temperature, Jim? Let me read it. 30. There's definitely a little bit of heat in there. It's dramatically different. Yeah, I don't quite understand, but it is dramatically different. Of course, we've gone from like about 650 ohms to 1,000 here. So, you know, maybe that's the big difference. Okay, just pondering things before I go ahead. Okay, stop pondering. Let's go ahead. Oh, I was going to check I did check it. It was 275. Wow, we're way over the plate voltage of those tubes. But the fact is, we could plug those tubes in and find this voltage drop way down. We'll probably have to do that. That wouldn't even work. Well, it would. Yeah, that wouldn't work because these tubes need the amplifier to set up the plate current draw on them. So they plug them in here the way things are. There'll be no plate current draw. So we really have to put them. I really have to check this with everything hooked together. But let's take a peek. Would anything really bad happen? What if this goes to 650 volts? That would be bad. We might have got 450, 425. Okay, that's enough for me to have a look. Let's knock it back down. That's really, really high. It's really, really high. Nowhere in the schematic have I seen any hint on what it should be. But maybe the hint's in there. Oh, there were voltage checks. There was a voltage table. Let's take a look at the voltage table. Okay, so in this manual is a table of numbers. Here they are. Prong, prong, prong. So we can guess where the plates are coming. These higher numbers. Another number of some sort is probably on the screen. So this is probably the plate here. Prong number 3 on most of these tubes. 270. And on the 45s, 300. 300 on the 2A3s. 370. Wow. I think I read 300 was the maximum. But, you know, the designers of this know what they're doing. So they're pushing it all a little higher, it looks like. 300 is really what we want to see. And it was what? 425. Oh my gosh. Sure sounds too high. Okay, but we'll leave it at that for now. Ponder what it is I may have done wrong here. If I did anything wrong. Maybe I didn't. Radio's working. Can't beat that. No smoke. Can't beat that. And I certainly hear a hum. Where's that hum coming from? The hum is gone. That's because I turned the volume down. So this guy is producing a hum. Well, I'll back that up. The way I have this connected into my sound system is picking up a hum. Exactly how and why I don't know. I really can't resolve the big picture until I hook this guy up to the amplifier, to the speaker that's in the cabinet. Okay, next step here. Probably is to check some plate, screen, and grid voltages on the tubes. If all that checks out well, then I'm on my way to leaving everything as it is. So I'm still hunting for a cause for these hot resistors, and I'm pretty sure I can see the paint has gone liquid on them again. Let me poke at it here a bit. Oh yeah, this is all melted here. Shiny. Yeah, it's all liquefied right in here. Liquefying at... So the paint they put on them is not only good till... Oops, just a sec here. About 50. I think the original designers of these resistors must have figured they would never get above 50. Or anywhere near it. Because look at the paint. I mean, surely to goodness they knew the paint's resilience. 77 on this one. 77 a little high. 30 on that. $55 on this one. And there's another one up in here somewhere, isn't there? But not showing a lot of heat. They're all too hot still. So that's another thing to work on is why are those resistors still hot? Too high a B+, drawing too much current through the tubes, drawing too much current through the resistors. I don't know. That's my guess for now. So thanks a lot for watching. I think we got this okay. I think. And onward.